Hey Valley Middle, welcome back to another G67 math video. Tonight we're going to be working with three-dimensional figures. Before we do that, let's start off with our trivia question of the day, just for fun. How long has the iPhone been around? I was kind of surprised by this answer. Officially tonight, our target. I can identify three-dimensional shapes and describe their properties. Let's do this thing.
Gosh, Kip, what the heck is that?
It's Uncle Rico's new painting.
No, I mean, like, what shape is it?
It's an octahedron, Napoleon. It has 8 faces, 12 edges, and 6 vertices.
What the heck, Kip? Where did you learn that?
I learned it chatting with babes online. That one never gets old, but if you can do what Kip and Napoleon were just doing, name a solid, describe it, the number of faces, the number of edges, and the number of vertices, you are going to nail this target tonight. We got a lot of vocabulary that I want to talk through you, so sit back and take a listen, and then our ticket tonight will actually be defining some of these vocabulary words, but let's work with them a little bit first. All right, first of all, let's just take a look at some basic vocabulary that you know, just to review. The vertex here where the edges meet, here are the edges. Edges are where faces meet, and then of course you have the base. Sometimes the bases are called faces, but I like to call them bases when they're on prisms because I always identify a prism by its base, and we'll talk more about that later on. But then it's just a matter of counting them up and identify them. And again, those are 5th and 6th grade targets. Let's take a look at the first more complicated word here, which is polyhedron. Kind of a scary word, but it's really pretty simple. Just slide my screen up here. So anything that's a polyhedron, these are closed figures and they're bounded by polygons. That's the big deal there. Polyhedron, polygon. You notice all the faces here are polygons. We got prisms, pyramids, and then you can, join them together and make like this cute little house. But it's all the faces then are polygons. Non-polyhedrons, take a quick look at them, and let me scroll down here. You're going to notice something they all have in common. Something round or circular, correct? Yeah, and though, circles aren't polygons, so anything with a round edge is going to be non-polyhedron. Okay, so we got poly, non-poly. Let's talk about prisms and pyramids. Take a look at the prisms here. We talked a little bit about this earlier, but a prism is going to be named by its base. So this prism here is a triangular prism, and this base, this face or triangular base here, is going to be perpendicular to the faces, and it's going to be parallel to the other base. So take a look at the hexagonal prism here. This hexagon here is parallel to the hexagon base on the other side. That's an important attribute. And then it's perpendicular to its faces. And so you've got octagonal prisms, hexagonal, pentagonal, rectangular. The square prism here, I think I stretched it a little too much when I put the image in. I'm sorry about that. But we name them by our bases. And the same thing with with pyramids. We name them by our bases too. We'll start down here with an octagonal pyramid. It has a base of an octagon and then triangular faces that meet at a point, so or at the apex. So this here, is an octagonal prism, a hexagonal prism, pentagonal, rectangular. Here's a rectangle here on the bottom. Okay, so that's what prisms and pyramids have in common. We name them by their base. So that's the second P. Let's get the third P down. We've got polyhedron and prism, and then platonic solids. And these are like kind of regular or convex polyhedrons. And I think the best way to describe them, I'll read this to you. It said it's constructed by congruent, which means identical, regular, which means all measures or all sides or all edges on the polygon are the same length, like a stop sign is a regular octagon. Each of the 8 sides is identical, so they're congruent, regular polygonal faces with the same number of faces meeting at each vertex. So the easiest way, I think, is to just take a look at some here. These are the 5 platonic solids. You can see how they come together. Notice how all the faces are the exact same size and they're regular. All the edges of the pentagon are the same, and all of the faces are those regular pentagons, the same size. They're congruent. So they make what I call gamer die. They look like the ones my friends were playing with Dungeons and Dragons in high school. Okay, so let me give you some of their properties. So this first one here, the tetrahedron, has 4 faces, 6 edges, and 4 vertices. It's triangular pyramid, right? Triangular base. This one here, the cube, you're very familiar with 6 faces, 12 edges, and 8 vertices. Here's the octahedron that Napoleon was talking about, and has a total of 8 faces, 12 edges, and 6 vertices. It really looks like 2 square pyramids that are fused together. The dodecahedron, let me just scroll up so you can see the properties of that. 12 faces, 30 edges, 20 vertices. And the icosahedron with 20 faces, 30 edges, and 12 vertices. So I want to show you one other thing. Here you can kind of get a better idea of what these look like. This is a net for the dodecahedron, but you see how they're regular pentagons and they're all congruent, the same size, and so when they come together, they're all going to meet at the same angles. Okay, well, we've gone through our vocabulary. I think the way you're going to be tested on most of this is just by taking a look at several of these and identifying their properties. I'm going to go to this one first. Here's 1, 2, 3, and 4. So once you number 1 through 8 on your paper, and take a look at these 4 shapes and identify, the number of faces, edges, and vertices for each. And I'll be back with you when you're done. Hey, I'm back. Let me click here. I think I should get your answers. For that first one, the triangular pyramid, we got 4, 6, 4. We'll always be talking faces, edges, and vertices. Number 2, the cube, 6, 12, and 8. We've already talked about. The pentagonal prism, 6, 12, and 6. And the square or rectangular pyramid, 5, 8, and 5. All right, 4 more. Why don't you give these ones here a shot? Okie dokie. Click in the answers for you here. Rectangular prism, like a cube, it's 6, 12, and 8. Hexagonal prism, 8 faces, 18 edges, 12 vertices. Triangular prism, we got 5, 9 edges, 6 vertices. And the old rectangular prism, there we go, 7, 15, and 10. Okie dokie. Well, that's about it. We'll be practicing working with those, identifying those tomorrow in class, counting them up, looking at some different forms of those. Tonight for your ticket to the show, I'd like you to define these terms. What is a polyhedron, a platonic solid, and a prism? I'm not having to identify or define pyramid, but those 3, you should be able to nail those. All right, our trivia question for tonight. How long has the iPhone been around? Well, let's start off by seeing what the first iPhone actually looked like. Here it is, back in the 1980s. Dude, check him out, my new phone. No, that really wasn't it, but I just like that picture. Here was the actual first iPhone. Nah, I'm just messing with you again, but I thought that was kind of funny when I Googled primitive phones. Actually, here's the first iPhone. It was released June 29th, 2007. So just 9 years ago. Doesn't look that much different than the original. So this is the iPhone 1, I guess you would call it. Anyway, I thought it had been around a lot longer than that. All right, thanks so much for listening. Have a good evening. Bye.